Hey everyone, this is Mrs. Slauson, one of the Algebra 2 teachers at Eagle Crest, and we are going to be going over ICANN number 10, the first attempt, which is covering graphing, and there is a typo here because it is not quadratic and cubic equations, it's actually square root and cube root equations. So with that, let's go ahead and get started. We do need to identify the transformations in each problem. So just starting with number 1, we have our negative here, which means it's going to be flipping or a vertical reflection. We have our 4 here. This is in our house. That's our H. The house just means it's contained in something. So here in this chapter, it is contained inside of our check mark, our square root. So I should take the opposite. I should look at it as -4, and that means I'll go left 4. And then this is our K. This is telling us to go up 3. So with that, what you will need to think about is what are numbers that you can take the square root of, and you can take the square root of them without a calculator, and those numbers will also fit on this little piece of graph paper that goes from -10 to 10 on the x-axis and the y-axis. So in this situation, the first number I can take the square root of without a calculator is 0, and again, the idea is I'm plugging that value in for x, taking the square root to get my y, so the square root of 0 is 0. The next number I can take the square root of is 1, and that's just 1. After that, I can take the square root of 4 and get 2, and then I can take the square root of 9 and get 3. So this is going to introduce us into our parent function shape, and if you take a look at number 3 below, you can get an idea of what this shape is going to look like. But now I'm going to start to apply my transformation, so I will be applying my flip to all my y values. And so 0 still is 0, but 1 is now -1, 2 is now -2, and 3 is now -3. And what I like to do is cross out those old y values so I just don't get confused with what I'm graphing. So what I'm going to be doing is starting at 0, 0. This point won't be staying there. What's going to happen is it's going to go left 4 and down 3 and end up right here. So I'm going to get rid of my 0, 0. Then I would be looking at 1, -1. And that is also going to go left 4. Left 4 and down 3. So it's going to end up right here. And then I will be looking at 4, -2, which starts here. And then that's going to go left 4 and down 3. And then finally, we are going to go to 9, -3, which is here. And then it will go left 4 and down 3. And so when I'm done, my shape looks like this. It's going to start here, and then it's going to go through those points and then keep going past that point, but I'll have an arrow. The main thing is the point that is where 0, 0 moved to does not have an arrow. All right. All right, let's go to the next one. This is a cubed root function. So here I want to think about what are numbers that I can take the cubed root of without a calculator to get their y values. So the smallest number that I can take the cube root of without a calculator is -8. That's going to be -2. My next number that I can take the cube root of is -1. It gives me -1. 0 gives me 0, and then 1 gives me 1, and 8 gives me 2. So at this point, we're going to take a look at our transformations. We have this 1/2, which means it's going to compress. It's going to get kind of mushed together. In our house, we have a -2, so I want to think 2, which is telling me to go right 2, and then this -6 is going to tell me to move all my points down 6. So what I'm going to do real quick is take all my y values and apply my compress. So I'm going to half all these values. And when I half all those values, I get some new values. So -2 becomes -1, -1 becomes -1/2, 0 is still 0, 1 is now 1/2, and 2 is now 1. So just like before, I do like to cross out my old y values so I can just remember my x values. And what is starting at -8, -1 won't be staying there. It's going to go right 2 and down 6. End up right there. And then I'll go ahead and just kind of estimate where I think -1 and -1/2 is, which is about there. I don't know if you can see that. But then that's going to go right 2 and down 6. So it ends up right there, right in between 6 and 7. And then 0, 0 is now going to go right 2 and down 6, end up right there. And then I just kind of slowly take care of all my points. And my last one of 8, 1 is going to go right 2, down 6. So 1, 2, 3, 4, 5, 6, about there. And then I can connect them, and this time I will have arrows at both ends. And that is 1 and 2. So the main thing you're going to have to think about, besides the transformations, are what are your parent function points. So get to know those, maybe write them down a couple times so that you have them memorized. Okay? Otherwise, what can you take the square root of and what can you take the cubed root of? Take the square root and the cubed root of those numbers to get your y's. All right, problem 3. So we have 3a, b, c, d, e, and I see some increasing, decreasing, positive stuff, so I'm going to take care of that. So the first thing I want to do is mark my important points. So I've got where it starts at 3, 4. This arrow on the right is going to the right and up. There are no turns, no like maxes and mins, and it doesn't cross the x-axis. So that's all I really need. So my first question, I want to know, where is this function g of x decreasing? And remember, we read a graph left to right, and this function, this graph, is actually not decreasing from left to right, it's increasing. So I'm just going to say not applicable, do that. Don't leave a blank. Acknowledge that you understand that there is no decreasing. Where is it positive? So its opposite is negative, and the whole thing is positive. Remember, we might be giving our answers in x, but we're looking at where is our f of x, where is our y positive. So going left to right, we start at 3, we go to infinity. Infinity always has parentheses, and our 3 is going to have a bracket because its particular y value is positive, so we want to make sure we include that. We do want to find our average rate of change, so these numbers are the x's. So if you look at your graph, if I give you 3, the y value is 4, and if I give you 7, the y value is 5. And average rate of change, if you remember the story about the table, you're going to have sturdy legs on the bottom, you're going to put your martini glasses on the top. You have to be 21 to drink, and drinking is bad for you. So anyway, what I'm going to do is go ahead and start with my y's. And what I like to do is the easiest way possible. So I'm going to do 5, take away 4. So in my numerator, I'm going to get 1. But that means when I subtract my x's, I'm going to have to go about it the same way. So I'm going to have to go 7 minus 3. And that's going to give me 4. So my average rate of change is 1/4. The other option you have, because we have a picture, is, average rate of change is just slope. You could just count your rise over your run. So start here, you rise 1 and you run 4, and it is going uphill from the 3, 4 to the 7, 1. So we would keep it positive. My range is my smallest y to my biggest y. So my smallest y is 4. And my biggest y is this infinity. And I will include the 4 because it is an actual y value on there. All right, the next thing we're going to do is we're going to write the equation for this. So it looks like this. And what I need to do is establish the numbers that I know. So I'm going to do a little erasing here on my picture. And the starting point, this 3, 4, kind of want to think of that as your h and k, and then this point that it's going through, this 7, 5, you want to think that is your x and y. So what we're going to do is we're going to substitute those values, and we're going to figure out what a is. So y is 5, a is going to be a, then I'm going to do the square root of 7, and I'm going to take away 3, and then I'm going to add my k, which is 4, and what I'm going to do is just kind of hang out right here and get this part cleaned up. So I'm going to end up with the square root of 4. And then I can actually take the square root of 4, which is 2. And now I'm able to solve for a. I'm going to subtract my 4. And then to solve for a, I'm going to divide by 2. So my a ends up being 1/2. But we aren't done. We rewrite the equation. And remember, when we write an equation, we want the same things as if we graphed the equations. So I want to know my a, my h, and my k, and then I'm still going to leave the other letters as x and y. So writing my final answer, I would write y equals a square root of x minus h plus my k, which is 4. And there you go. So on number 4, we're just going to do a cube root just so you can see the difference between these two. So the only thing that's going to change is you're just going to have a cube root there and not a square root. So in this problem, our h and k is kind of right there. It's 2, 1. And then this other point here, which is 3, 5, that's going to be our x and y. And when you do your other ICANNs, you will see these clearly marked points, so you shouldn't have a guess as to what's what. But I'm going to do the same thing. I'm going to put y in, figure out what a is. I'm going to take x and subtract h. I'm going to add my k, and then I'm just going to spend some time here. And to do that, I'll have 5 equals a with the cube root of 1. So still just kind of hanging out here. The cube root of 1 is 1. And now to get a by itself, I'm going to subtract 1. And then I'll divide by 1, so I get my 4. And just like before, when I write my answer, I'm going to write it as y equals the a value. Don't forget your little cube root, x minus my h plus my k. All right, so that is ICANN 10, first attempt, and now let's take a look at a spiral. So we're going to determine if the following are non-one-to-one, one-to-one, or just not a function at all. So as far as your test goes, not a function fails the vertical line test, and you don't even have to worry about the horizontal line test. A non-one-to-one function passes the VLT but fails the HLT, and then your one-to-one function passes both. So looking at number 1, it is passing the vertical line test, but it is going to fail the horizontal line test. So it's going to pass my VLT, it's going to fail my HLT, which is just going to make this non-one-to-one. All right, number 2, it also passes the VLT and fails the HLT. So this is going to be non-one-to-one. And then the last one actually fails the vertical line test. So no need to continue. This is not a function. All right, number 3, let's review some solving and then we're done. So I think what I'm going to actually do is I only have about a minute and a half left on this video, so I'm going to stop and just start a new video.